Hey there, let's try to solve this problem on minimum penalty for a shop today. So let's read the description together. First, you are given customer with a log of a shop presented by a zero index during customers consisting only of characters M and Y. If the ith character is Y, it means that customers come at the ith hour, whereas N indicates no customer come at the ith hour. If the shop closes at jth hour, where J could be closed at 0, it means that it closes at the first hour. It means that it never opened, or it can close at N. It means that it never closed in all the hours. So the thing is, we really want to select best time to close the shop in order to avoid some sort of penalty. So if the shop is open and there's no customer come, there's one penalty. That makes sense because you open a shop, but there's no customer. You're basically wasting a lot of resources or electricity, etc. On the other hand, if it is closed, but a customer account, and then there is one penalty. That makes sense because you cannot serve the customer when you have the chance. Okay, let's take a look at this example. If we close at 0 hour, we get free penalty. Why? Because if we close at 0 hour, that means we cannot serve this customer, which is coming at 0 hour, and we cannot serve this customer as well, and we cannot serve this customer as well. So in total, there are 3 customers that we cannot serve. That's why we have 3 penalties. For the second, if we close here, we cannot serve this particular customer, but we can serve this customer. So there's no penalty here, but we have penalty here. We cannot serve the second customer, and we cannot serve the last customer as well. So there are 2 penalties. As for this one, if we close in here, we can serve these 2, so there's no penalty here. And then because we close here and there's no customer in this hour as well, so there is no penalty for it too. But we have 1 penalty for not serving this customer. So that's why there's 1 penalty. And for this one, we are choosing to close at this time, so we cannot serve this particular customer, and we are opening on this particular hour, but there's no customer coming in this hour, so there's 1 penalty as well. So in total, there are 2 penalty. Lastly, if we choose to close the shop at 4th hour, it means that we never close the shop. So this customer, or rather this time slot, no customer, but we still open the shop. So there's 1 penalty for it. However, we want to choose the earliest time for penalty. Even though they have the same penalty as it mentioned, we will choose to return second as the final answer. That's pretty much all for the problem description and example. And let's think about how to solve it. So one easy way to think of a solution is to just do the brute force. For example, let's say if I want to choose to close shop at ith hour, then what is the answer? So for example, if I want to choose to close the shop at ith hour, for example, in here, basically, I need to know how many y are there from here all the way to the end. It's not I plus 1, it's from I all the way to the end. Because if we're closing at I hour, then every y starting from I is going to have a penalty. So this is y count and I all the way to the end. This is the first kind of penalty, but there is another kind of penalty where we open the shop, but there's no customer in there. So the second part of the equation is basically n count starting from 0 all the way to I minus 1 because we are closing at I, right? So the last time we open is I minus 1. So from 0 to I minus 1, how many n are there? And that is the answer. So we're gonna iterate for every I, and then for every I, we're going to calculate this thing. And then at the end, we're just gonna pick the minimum penalty that we can find. And that's pretty much the gist of the solution. And we can pretty much achieve a solution in time O(n) and space O1. That's pretty much all. Let's take a look how can we actually solve it in code. And it's going to be the length of the array and n count, which represent the number of n starting from the beginning all the way to I minus 1, and y count to the end represent the number of y starting from I all the way to the end, and result we initialize it as n, which represent the best time to close the shop. And we also have mean penalty that we can find so far. We initialize it as n. So first we're going to make y count to the end equals to the number of y starting from 0 all the way to n minus minus 1 is basically is every y that we can find in the customer's array. So right now it's 0. It doesn't make any sense. We want to make it at least first at the number of y from 0 all the way to n minus 1. Then we can subtract each time we see a y from left to right. So we will do basically that here. So we iterate for every customer. If customers y, then we just add 1 to our variable, and then we will iterate the loop here. For every I, we are trying to close a shop at I. So if we are trying to close a shop at I, what is the penalty? As we mentioned, if we close a shop at I, it means that we open the shop from 0 all the way to I minus 1. Therefore, during this time, every n count, it means that every time that there's no customer, there's a penalty. And also because rows at our I, so all the y count till the end, it means that because we close at our I, and every y that we see from now on all the way to the end will have a penalty. So that's the total penalty, but that's not the answer. It's just the answer if we choose to close at shop at RI. So if current penalty is less than the mean penalty, less than, I mean strictly less than, because if it is equal, then we will prioritize choosing the earliest index as the prompt description mentioned. So if the current penalty is strictly less than the minimum penalty that we can find so far, we have a new answer, and then we will just choose to update the penalty and also update the current answer to I, and then we'll update the n count. The n count should plus 1 if the current index of the array is n, and similarly we should subtract by 1 if the current index is y, and eventually we just return the result that we can find. Okay, that's pretty much all. Let's try to submit it. Okay, accept it, and that's pretty much all for today. Thank you so much for watching, and I'll see you next time. Bye bye.